Have you ever cracked open an old gadget and seen that circuit board inside? You know, the green thing with all the tiny little components soldered on? Well, a ton of those little pill-shaped things with the colorful stripes are called resistors, and they are, without a doubt, one of the most essential pieces in all of electronics. So let's figure this out. What do they actually do, and why are they in literally everything?
Right? I mean, you see them everywhere. In your phone, your TV, your car, everywhere. But what is their actual job? What purpose does this tiny, super simple-looking part really serve?
Well, before we get into the nitty-gritty, here's the main takeaway. Without resistors, most of the electronics we use every single day just wouldn't work, period. They are kind of the unsung heroes of every circuit, quietly doing a job that is absolutely non-negotiable.
To really get why they're so important, we have to start with their main job. You can think of them as the traffic cops of the electronics world. Okay, so the name itself is a huge clue. A resistor's job is to resist the flow of electricity. It's what we call a passive component, which is a fancy way of saying it doesn't need its own power source to work. Its power comes from just being there, getting in the way.
Here are a couple of great ways to picture this. Imagine electricity is water flowing through a garden hose. A resistor is like you stepping on the hose to slow that water down to a trickle. Or think of a busy highway. A resistor is like closing a few lanes, creating a bottleneck that slows down the flow of traffic. Same idea.
And this whole idea is wrapped up perfectly in a super important rule called Ohm's law. It's a simple formula, but it runs everything. Basically, the more resistance you add to a circuit, the less current can get through. It's this beautiful, simple relationship that engineers use to control pretty much everything. Okay, so they slow down current, but so what? Why is that even a useful thing to do? Well, it turns out that controlling the flow is one of the most critical jobs in any circuit. Let's see why. Check this out. This is a perfect example. An LED, you know, those little lights you see on everything, is super sensitive. If you just hook it straight up to a battery, a massive surge of current will flow through it, and poof, it'll burn out in a split second. But if you put the right resistor in there, it acts like a guardian, limiting that current to a safe level so the LED can shine on without destroying itself. And protecting little LEDs is just the beginning. Resistors are like the Swiss Army knives of electronics. They're used to split up voltage, to clean up electronic signals, to get other components like transistors working just right, and even to burn off extra energy as heat. They're incredibly versatile.
All right, so if every resistor has a specific job and a specific value, how in the world do you tell them apart? They're way too small to print numbers on. Well, this is where it gets kind of fun. We get to play detective.
I love this way of putting it. It really is like a decoder ring. Those little colored stripes you see on every resistor, that's not decoration. That's a secret code that tells you its exact value.
So on a standard 4-band resistor, here's how it works. The first two colored bands give you the first two numbers of the value. That third band, that's the multiplier. It tells you how many zeros to tack on at the end. And that final fourth band tells you its tolerance, which is basically how accurate it is.
And this is the decoder ring itself. Each color corresponds to a number, from black at 0 all the way to white at 9. Once you know the system, you can use these charts to figure out the value of pretty much any resistor, whether it's just a few ohms or millions of them.
So about that last band, the tolerance band. If it's gold, that means the resistor's actual value is within 5% of what the code says. If it's silver, it's within 10%. For most projects, that's plenty good. But for really sensitive stuff, that precision matters a lot.
Now, reading color codes is a great skill, for sure. But what if the resistor is old and the colors are faded? Or maybe you just want to be 100% positive you've got the right one. Well, thankfully, there's a much more direct way.
Say hello to the multimeter. If you're going to get into electronics, this is an absolutely essential tool. It does a bunch of things, but for our purposes, it can measure resistance directly. You just set the dial to the ohms section, that's the little omega symbol, and touch the probes to the resistor's legs.
You'll generally see two kinds. They're the older, analog ones with a physical needle that moves across a scale. They work, but they can be a little tough to read accurately. But then you have modern digital multimeters, which just show you the exact number on a screen. No guesswork, no squinting.
And I mean, just look at the difference. On the left, with the analog meter, you're kind of trying to eyeball where that needle landed. But on the right, with the digital one, boom, it just tells you the answer. It's a total game changer, especially when you're just starting out.
Okay, listen up, because this is the single most important rule of measuring resistance. You absolutely must make sure the circuit has no power going to it. None. If you try to measure resistance on a live circuit, you're going to get a totally wrong reading, and you could easily destroy your multimeter, the circuit, or both. So always power down first.
So, there you have it. You now know what a resistor is, you know why it's so important, and you've got two different ways to figure out its value. You can officially look at a circuit board and have a much better idea of what's going on. You've unlocked one of the key secrets of electronics. So the only question left is, what are you going to build with this knowledge?